I'm Chigoshi. I'm the CTO and co-founder of Saturn Cloud. I've been working with and working on data science tools for more than a decade. Today, I'm going to talk to you about why data science platforms are bad. We'll go over why you may or may not need a data science platform in the first place, why they tend to be bad, and what you can do about it, or really how to choose one that's the least bad, if you need one at all. All right, to motivate the discussion, I want you to travel back in time with me to a bygone era. And by bygone era, I really mean 2009. 2009 was a wild time. Pandas didn't really exist yet. Technically, Pandas did exist, but it wasn't popular. No one used it. I'm not even sure if it was open source at that point. At that time, you were still doing most of your work in NumPy directly, and maybe you would consider Pandas or its competitor Larry. And that's if you were even using Python at all. Most data science back at the time was in MATLAB or R, or even Java. There was no Jupyter notebooks, right? It was just IPython, which you would run inside a terminal. In 2009, I was responsible for tasks like cleaning data, training models, and creating analyses. And I was doing this at an options market making desk. All of my work was done on a Windows desktop computer that was assigned to me when I started working for the company. We would usually save analyses into CSVs or Excel spreadsheets. Then we would either mail them to the people who needed it or save them to a shared drive. And there are times where we needed to automate some of this. So we would run cron on a Linux server, or more commonly, we would run Windows scheduled tasks on our desktops. I had 4 desktops sitting under my desk running production workloads and Windows scheduled tasks on a daily basis. So a lot of things are wrong with this picture, but let's break them down. First of all, hardware is limited. If you have a physical desktop or laptop, your hardware is fixed. There's no way to adapt it. You can't use more memory as your data volumes grow because your physical device has a finite amount of memory in it. My machine had no GPU. Most laptops these days don't have deep learning grade GPUs in them, so entire classes of models aren't practical. Your only workaround is to focus on smaller subsets of data, avoid certain classes of models, or limit the number of parameters you want to scan through in a parameter scan. Sometimes this is okay, but it's always a limitation, right? And it also means that focusing on making your code more efficient, which is always an important thing to do, becomes much, much more important. There are also operational limitations to this, to how dependable, reliable, and reproducible things are. I set up these machines, these 4 desktops running our workloads manually. They were imaged by my IT department, then they brought them over to my desk, and I would install whatever libraries I needed on those machines. And if someone wanted to rerun my analyses, they would have to replicate everything that I did. And I definitely did not document it. When you're working on a development machine, your actual runtime configuration is just an accumulation of everything that you've done to it over time. If you try to install a new program or you update some libraries in your OS, or you're experimenting with different versions of Python or R packages, that accumulation all ends up being what you're working with. And so you can sort of write documentation for what you think will reproduce the state of your machine, but it's never going to be accurate. There are tools now like Conda and Pip and Poetry that definitely help, right? If I've got a Conda environment on my system, it's pretty easy to replicate that environment elsewhere. But that's not, the exact same thing that I'm running. Unless you're doing all of your development work in Docker, you're coming up short. There's also limitations around reliability. So even if I had perfect documentation for how to set up a system, the system is not very reliable. If one of my 4 desktops had a hardware failure, it would take a significant amount of time to reinstall things on them. And back then, like, a lot of these libraries were not installed from pre-built binaries. They were, installed from source, right? with Fortran dependencies and such. No one knew how to maintain this. So when I went on vacation, I had to be within cell phone range so that I could assist if something went wrong. In 2009, I didn't have a laptop, but everyone's got laptops now, and there are similar issues here. If your laptop gets stolen, you could lose months or weeks of work. The data scientists I know aren't always the best at remembering to push everything to Git, if they're even using Git at all. And I know that, best practice is that you should be pushing to source control very frequently, but realistically, that doesn't always happen. All right. So I painted a very bad picture of what my life was like in 2009, and now it's 2022. So things are different. Things are definitely better, mostly because the use of Docker is much more popular and much more common, and because companies are doing much more work in the cloud. However, most data scientists are still not using Docker as their daily development environment. Most data scientists still do ad hoc deployments to servers that are manually configured. Most data scientists are still working on local machines. We can divide teams in 2022 into 3 categories. There's the local machine camp. The local machine camp, I think, primarily retains all the problems that I had in 2009. Then there's a group of teams that work on cloud instances. So these teams, they have laptops, but oftentimes someone, maybe them, will provision EC2 instances that they can SSH into and run stuff. That somewhat solves some of the hardware scalability issues, but doesn't generally address any of the other issues that we had. And then finally, there are teams that have adopted or built out a data science platform. And of course, in that situation, your limitations are basically like how good or bad your data science platform is. So what is a data science platform? The data science platform is a collection of tools. And it's less important whether you actually have a cohesive platform that you bought from a vendor. And it's more important that all these capabilities are met in your organization, whether it's through a collection of tools that you've figured out how to get them to work together well, or whether you built your own platform, or whether you purchased the vendor product that does all of these things. So let's go through them. Data scientists need the ability to do exploratory data analysis and create machine learning models. And I really mean that this has to be able to happen on scalable hardware. Data scientists need the ability to deploy models as APIs for other teams at the company to use. Data scientists need to be able to schedule jobs and data pipelines that are necessary to keep the business running. They need to be able to deploy dashboards, which present this data to executives, stakeholders, and other people at the company. And finally, they need to be able to collaborate with members of their team easily on their work. And when I say collaboration, I don't necessarily mean real-time collaboration, though that's definitely nice. I think the test for that is, if I'm working on a project, can my colleague run the same thing that I've been running and then start contributing to it? Some data science platforms also bundle MLOps into it, but I would say that those address different problems. So what is MLOps anyways? This talk isn't about MLOps, but we'll go through this very quickly. And this is from Neptune AI. So thank you, Neptune. Lots of love from Saturn, in keeping with the planetary theme. So MLOps is a set of tools for operationalizing machine learning, right? And this example pipeline goes through data sourcing, labeling, versioning, and then, training and evaluating models, all the way to versioning them and deploying them and monitoring them. I would argue that data science and MLOps are different. There are many overlaps in the sense that data scientists will sometimes spend their time training machine learning models, but much of data science doesn't actually involve machine learning. And many data scientists will produce machine learning projects that don't reach the scale in their organization where they need rigorous operationalization. This talk isn't about MLOps, but I just wanted to bring that up because people sort of confuse these categories all the time. So what's bad about a data science platform? Oftentimes, and again, these negatives are going to be dependent on the product that you choose, but these are things that we've observed over time. Many platforms will try to change how you work. And some of these will argue that the guardrails that they put in place are for the benefit of your team or for the benefit of the data science team. And I can understand why that may or may not be true, but ultimately, I think they usually do a disservice to the team that's using the platform. So let's go through the list. Many data science platforms will force Python code to be packaged in highly specific ways before it can run on the platform. Oftentimes, they don't really understand Git branches, and so they'll force data scientists to use only a single branch of a Git repository. They'll often force data scientists to keep all of their work in a notebook, and that's usually a single notebook because you can't oftentimes import code from other notebooks. They will also limit which programming languages can be used, and usually that means that you can use Python, but you can't use R and you can't use Julia. They'll also limit the IDEs that data scientists can use. Many of these limitations I feel like are especially egregious because they discourage software engineering best practices. And I know that data scientists are not software engineers, and we don't expect data scientists to adopt the latest and greatest software engineering principles. But the last thing I think we want to do is to discourage the production of higher quality, better tested, and more reliable software. That's in the opposite direction of where we want to go. But we have products out there that point people in the wrong direction. What's also bad is that there's too much of an emphasis on notebooks. If all of your code is in notebooks, how do you unit test them? If all of your code is in notebooks, how do you import them into other notebooks? And I know that there are packages that sort of help you do that, but those are really workarounds to code living in notebooks in the first place. Software engineering, source code should be regular source code, right? It should just be Python files or R files that you can import as libraries, right? There are established ways of writing Python code that's very good. Notebooks should be used as a development, exploratory research environment, but data scientists still need to be writing library code that they're going to be then relying on in their analyses. And the last thing is that modern IDEs are really, really, really good. These days, I almost never write Python imports. I just write Python code, and then PyCharm will tell me that, this thing isn't imported, and I'll mash my keyboard, and then PyCharm will figure out or ask me what I actually wanted to do, and it'll fix it. And it's almost always correct. Forcing data scientists to use web-based IDEs where many of these basic safeguards that prevent you from writing bugs, like things that prevent you from making typos or misspelling attributes that you're trying to access or calling functions that don't exist because you misspelled the name of the function. All these basic safeguards are oftentimes missing from the data science platforms that people are using. And I would argue that this problem is way worse for data scientists because data scientists are usually not writing unit tests. So if they develop a bug that they wrote, it's usually in the middle of their experimentation cycle, right? And so they may have a program that loads data for 20 minutes and then does some more feature transformations for the next 10 minutes. And so it's 30 minutes into your program that you get the stack trace that you need to solve. Modern IDEs will often catch these problems as you're writing it, and it just saves you a ton of time. Modern IDEs will help data scientists save a lot of time and not produce mistakes. Finally, many data science platforms will lock you in. Vendor lock-in is a real issue. You need to ask yourself if the code that you're writing in the platform can be run outside of the platform. And a related question here is, are you using a ton of vendor-specific APIs? Right? Because if you are, then if you wanted to port that code outside of the vendor, those APIs are no longer going to work. And I'm not saying that you should not use a vendor. I'm a vendor. But if a vendor goes out of business, or if a vendor drastically raises their prices, or if a vendor discontinues a product, or makes some other change that has a negative impact on your business, you need to be able to extract yourself from that problem. Data science is also fundamentally about research, and that means that you're going to need to try many new things. For example, if you wanted to experiment with Dask or Ray, is that possible? How hard is it to do that? I'm not saying that the data science platform that you're using has to support Dask or Ray. It is impossible for any data science platform to support everything because new things are being developed all the time. But they need to be open enough such that if you want to experiment with something that's not supported, that's possible. What about Saturn Cloud? So I'm going to go through a real quick demo to sort of show you what Saturn Cloud does and how it works. All right, so this is Saturn Cloud. Saturn Cloud is a tool for managing computational resources, and there are 4 types of resources. The 2 on the left, the Python server and the RStudio server, are interactive development environments. They are what people will typically use for, what data scientists will typically use for their research and development. The 2 on the left, the deployment and the job, get closer to the production side. The deployment is a service that runs all the time. We use these to host dashboards, to deploy models, and to deploy APIs. A job is something that runs and then completes, usually on a schedule. And so we use this for things like data loads. I'm going to go into creating one, and that will give you a sense of how it works. On the hardware side, we support anywhere from 4 gigs of RAM to 4 terabytes of RAM. For GPUs, we support T4s, V100s, and A10s. We have a curated list of instances from AWS, but any instance that you want can be added quite easily. Everything that runs in Saturn Cloud runs in a Docker container. We ship a number of images with Saturn Cloud that are pretty good, but most enterprises that we work with end up building their own images because there's no way that we're going to know what packages you need. Data scientists can install packages at runtime in order to customize their environment. And so a very common pattern is to use an image, install some packages at startup, and then when you're happy with it, you'll go to our image builder and build an image. So I can show you what that looks like. Here's an image that I have, and if I want to make a new version of this image, I can just drop in this environment.yaml. I can customize it, customize any pip packages, apt-get packages, and then any bash scripts that I want to install, and then click build. An image will be built and stored in my ECR. We also have Git integration. So Git repositories, using the Git integration is less important when you're doing a development environment because you can always spin up a terminal and clone the repository that you want to use manually. However, we also support deployments and jobs, which are non-interactive environments. And the only way for you to get your source code onto those environments is to use the Git integration. So that's where the Git integration becomes the most important. In terms of other features, there's a couple of key ones. One is the ability to support SSH connections. So we support SSH connections from your local machine into the resource that's running. And this is pretty critical because that's what enables us to integrate with VS Code, PyCharm, and any other IDE that you want to use. And I actively encourage people to use desktop IDEs because they tend to do a better job at giving you a full software engineering experience than Jupyter notebooks, right? We can also run support for Docker so that within your Jupyter server or within your development environment, which is running in a Docker container, you can also run Dockerized workloads. If I go to one that I've already created, one thing that I want to show you is creating a deployment. A deployment is just like the development environment that I set up. The only difference is that you have to tell me what command to run. And so this is intentional because we want to make sure that anything that you're doing in development can easily translate into a deployment or a job. So as long as you can tell me what command runs your application and you serve on port 8000, we can deploy your program. And the same thing goes for jobs. And in fact, because of this symmetry between resources, once I have something running in Saturn Cloud in a development environment, I can easily clone it into a deployment or a job. I can also download a recipe. So everything in Saturn Cloud is backed by this JSON blob. So I'll show you what this one looks like. It's just a specification of what makes up this server, and it includes all the packages that are installed, what Docker image is running, any credentials that are being attached, the Git repositories that are being loaded. And we actually use this to share projects. So Saturn Cloud is sponsoring the Open Problems in Single Cell Biology NeurIPS 2022 competition. And one thing that we're doing is enabling people to run notebooks that are pre-configured with some boilerplate code for competing in this Kaggle competition on Saturn Cloud. And the way that this Run in Saturn Cloud button works is that it's really just a link to these JSON files, right? And again, this is just like the file that I showed you earlier, except this one's a little bit more complex because it's doing some real stuff. All right, let's get back to our slides. So what about Saturn Cloud? As I mentioned, Saturn Cloud supports SSH. And so we can support any IDE, including PyCharm and VS Code, right? So data scientists that are running on Saturn Cloud, when they're ready to graduate from something like Jupyter into a full-fledged IDE that can, has code complete and all these fancier capabilities, they can easily do so. Code that runs in Saturn Cloud is just regular code, running in your Docker containers, running code from your Git repositories. It's completely portable. This is extremely important. It's very important that any code that runs in your data science platform be completely similar to code that you would write outside of that platform. That way, it can integrate with any other tool or any other infrastructure that you're going to need to use in the future. If your code is written for the platform, you're going to be tied to that platform forever. Finally, unless you're orchestrating Saturn Cloud, you don't need to use the Saturn Cloud API. If you're using Saturn Cloud DAS clusters, you are technically using our API, but it's very easy to replace those with Saturn Cloud DAS with any other DAS cluster that you choose. And similarly, we're planning on adding Ray clusters. And when you add Ray clusters, it's going to be the same way. You can use Saturn Cloud Ray clusters or replace the Ray cluster in your code with any other Ray cluster that exists. So what now? If you don't have a data science platform, you might want to think about getting one. We went through a lot of the pain points of working without a data science platform and what you get if you adopt one. And again, what's more important than adopting a platform is just having all these capabilities met, right? The ability to do exploratory analysis on scalable hardware, the ability to deploy APIs and dashboards, the ability to deploy data pipelines, and the ability to collaborate. If you're going to get one, don't get a bad one. And if you're looking for one that's not bad, Saturn Cloud is not bad. But there are others, so you can look at those too. Thank you very much for your time. Goodbye.